So, we have learned about the series and parallel connections and how the voltage and currents and resistances can be calculated in series and parallel connections. Just to recall how all devices at your homes, how they are connected, in series or in parallel. What will happen if they will be connected in series? For example, you unplug, let's say, you unplug computer. What will happen?
Everything will go off.
Nothing will be working because they're in series. But it's all in parallel, so they all can work at the same time. Plus, they all will have the same voltage. Now, what is very important application of the series connection is so-called voltage divider. Voltage divider. Voltage divider. So, if you have, for example, you have power source that providing, let's say, 20 volts, but you require 5 volts or something. So we can use so-called voltage divider to get the voltage you need. But the most important, the voltage dividers are used in all control circuits. Which circuit where control, for example, temperature. We have air conditioner, you can set some temperature. When it's automatically turned on, when it becomes hotter than certain temperature, and when it cools down, it turns off. And that's done with the help of the voltage divider. Or, for example, have the lights outside, when it becomes dark, they turn on automatically. Again, it's done with the help of the voltage divider. So in many control circuits, voltage divider is used. So what is voltage divider? Let's say we have voltage supply that will be between this will be voltage in, and then we have two resistors connected in series, and we take voltage out from one of them. That will be voltage out. And let's say this resistance has resistor R1, this has a resistor R2. Let's find out what will be the voltage output of this very simple series connection. First, what will be the effect? Will be total or equivalent or effective resistance. Yes, how we find it? R1 plus R2. This is series connection, R1 plus R2. So, what will be the current flowing here?
R squared.
How we find in current? We have voltage and resistance, how we find in current?
Voltage over.
Using Ohm's law, yes. We have voltage in over resistance, which is R1 plus R2. That will be current flowing in this circuit. And then what will be voltage out? Because voltage out is the voltage across resistor R2. How we can find it? Using what? We have current, we know current is the same through in the series connection. We have found current and we know resistance. How we find voltage? Yes?
Current times resistance.
Yeah, Ohm's law, current times resistance. So we'll have current, voltage in over R1 plus R2 times R2. Just rewrite it as voltage out equal R2 over R1 plus R2 times voltage in.
Wait, why is it R2?
Because we taken voltage out from second resistor. So voltage out is voltage across resistor 2. So we apply Ohm's law to the second resistor.
So wouldn't it be voltage in over R1 plus R2?
Voltage in over R1 plus R2
But then
times.
you wrote
I just swap those,
Oh, yeah.
because if you have A, B, A times B is the same as B, A. So then just to have ratio of the resistances. Because I'll show you in a minute that using ratios it will be much easier to do calculations. Yes?
What are those symbols mean with voltage in and voltage out, the circles? What is that?
Are connections. Just connections. We have connected voltage in connected here, some power source here,
Oh, so about.
and we take in voltage out. It's not any device.
Yeah.
It's just at this point we connect to this, we connect to power source, and here we take voltage out.
Yeah.
Now let's consider the next example. Let's say voltage in is 12 volts. And let's say R1, resistance 1, let's say 18, this is 18 ohms. And this is 6 ohms. Let's find out what will be voltage out. So we supply voltage, you supply 12 volts across these two resistors, and you take in voltage output from 6 ohm resistor. What will be the voltage out in this case?
It's
Using this formula,
It's 6 over 6
24,
plus 18.
we will have 6
3.
over 24
Which equals 4.
times 12.
Oh yeah, times 12.
So we will have, substituting numbers, voltage out
It's 3.
will be equal 6 over 6 plus 18 times 12, and what that will be equal? 3 volts. So you have 3 volts output, so we have 12 volts, we get 3 volts. Now, we can do the same thing without using this formula, using ratios. Using ratios. Voltage is divided in the same ratio as resistors. Voltage is divided in the same ratio as resistances. So what is the ratio of the resistances? We have 6 to 18, which simplifies to
1 to 3.
1 to 3. Can we divide 12 volts in a ratio 1 to 3? 1 to 3.
Yes.
Yes.
What it will be?
9 and 3.
It will be 12 volts dividing this ratio will be 3 to 9. So we have 3 volts here, 9 volts here. So using ratios, we can easily find how voltage is shared. Yes?
I don't understand when you did 12 feet, I got to 3 to 9.
Hmm?
Like, you know how I went from 1 to 3, 1 to 3, from 3 to 9?
From here to here, how I get from here to here?
Yeah.
Okay, we have a ratio of resistances, 1 to 3.
Yeah. I get that.
So voltages has to be in the same ratio. How we divide 12 volts in the ratio 1 to 3? How many parts altogether we have? 4. To altogether 4. 12 divided by 4, 3. So 1 part 3 volts, 3 parts 9 volts.
So you add it. No, I don't edit, but it's just like.
You add those things. Fine. That's, yes?
I need a little.
Okay, that's all new material for today.